question 6, it gives you this reaction, and it says the polyatomic ion that is commonly abbreviated as EDTA. The ion can form complexes with metals in aqueous solutions. A complex of EDTA and barium ions forms according to the equation above. So don't let the fact that this is something you don't recognize freak you out. You've got this, okay? A 50 ml volume of solution has a concentration of 0.30 molar, and it's mixed with 50 mils of 0.20 of the barium nitrate to produce an 100 ml solution. Okay? Consider the value of K for the reaction. Considering the value of K for the reaction, determine the concentration of your barium EDTA in the 100 ml solution. Justify your answer. So since your value of K is so large, we can assume that almost all of your reactants become product. Okay, so we need to figure out which of those two reactants is your limiting reactant, right? Because we can assume all of barium is going to react and all of EDTA is going to react. So if we figure out the concentration for each of those, remember M1V1 equals M2V2, I know the volume of EDTA and its concentration, and I know the volume of barium nitrate and its concentration. When I actually do that work, right, I'm going to take for example, for barium, I would do 0.2 times its volume, the 50, and then I would divide that by 100, okay? So its concentration is going to be 0.1, while for EDTA, it's going to be 0.15. So that tells me that barium is going to be my limiting reactant, and therefore the concentration is going to be about 0.10 molar for the barium EDTA, okay? So I got 1 point for indicating that the equilibrium concentration is the same as that of barium, right? Because all of barium becomes barium EDTA, and 1 point for the correct concentration. Okay. In B, it says the solution is diluted with distilled water to a total volume of 1 liter. After equilibrium has been reestablished, is the number of moles of barium present in the solution greater than, less than, or equal to the number of moles of barium ions present in the original solution before it was diluted? So since I am diluting the solution, I need to be thinking about Q and K in this situation. Okay? So if I'm adding water, what that means, I'm going from 100 mils to 1 liter. So that means I am decreasing the concentration of each of these. I'm dividing it by 10. Okay? And if you don't believe me, actually do the math out. You have 100 milliliters. You are adding enough water to increase that volume by tenfold, which means you are decreasing the concentration by 10. So if I consider my Q, okay, let's look at this. My concentration would be 1/10 the value, but then also the concentration of barium and EDTA would be 1/10, which means that my Q is going to be larger than my K. It's actually going to be 10 times my K, which means since my Q is greater than K, that means I'm going to shift towards my reactants. I'm going to have my reactions going to proceed towards the reactants, which means that the number of moles of barium is going to be greater than that in the original solution. Okay, so I like actually, if you can read the other explanation, but I like thinking about it in terms of Q and K and being able to actually calculate it.